Hello, and for today's problem, we're going to be doing 509 Fibonacci number. So the Fibonacci numbers, commonly denoted as f of n, form a sequence called the Fibonacci sequence, such that each number is the sum of the two preceding ones starting from 0 and 1. So to give a formula for this, we have f of n, which is equal to f of n minus 1 plus f of n minus 2 for everything greater than 1. And if it is 1, you want to have that value f of 1 equal to 1, and we want to have f of 0 equal to 0. We have a couple of examples over here. So we have f of 4 is equal to f of 3 plus f of 2, which is equal to 2 plus 1, which is equal to 3. So given the input n equals 4, we want the output 3. So there's a number of ways to approach this solution. The first one would be just to kind of like get the nature of this formula and use recursion in order to call the Fibonacci method over and over and over again. So I'll just code it up really quickly over here. We have the base cases, which is 0 and 1. So we do if n equals 0, we want to return 0 like it says. And then if n equals 1, we want to return 1. Otherwise, we want to return the Fibonacci of n minus 1 plus the Fibonacci of n minus 2. So that'll just call the method recursively on itself, and eventually when it does get subtracted to the point where it's either 1 or 0, it'll turn 0 and 1, and that's where it'll end. So if you do a quick run over here, submitted, it works as expected. So this is a valid solution. However, the more you call the same method over and over and over again, while it's actually occurring, what's happening is all the methods and the the numbers being stored within the method are all being put onto the call stack. And over time, for very large Fibonacci numbers, this might compound into like a lot of memory usage, right? So we want to have some sort of way to prevent that. One way to prevent it would be by using a memoized solution. So you could have a hash map that stores the already completed values, and you would then have an extra guard in the in this kind of code statement over here to check to see whether or not that value has already existed in the hash map. So you could do that. Another way to do this, to avoid having to call the method itself again over and over and over again, would be to do it iteratively. So I'll do a little explanation through code over here as well. Imagine you have two variables here. We have 0 and 1. Now we can start off here. Those can be the base cases. So f of 0 and f of 1. What we can then do is for every single number from 0 to n, what we could do is make a equal to b, and then b equal to a plus b. So to kind of visualize how this works, we can take a look at the number 4, for example. So you start off at 0 and 1, which are the base cases, and let's a equals 0, b equals 1. So you start off at you want to loop through it 4 times, from 0 to 4, I mean. So you want to loop through it like that. At the very first iteration, what's going to happen is a is going to become 1, and b is going to become a plus b, which is 0 plus 1, which is also 1. So that's the very first iteration. As you keep going on forward, you notice that, let's see, a equals b, which is 1, a plus b, which is 2. It'll keep going on forward until it reaches the end, and you'll notice that it's actually equal to the final value, which is 3. So yeah, instead of having to call the method over and over and over again, backwards, and having to store all those values in this call stack, what you could do is iteratively keep a kind of temporary variables which shows what the current number is so far until you reach the number n, where you'll then reach your final achieved result. So at the very end, what'll happen is at the very end of the iterations, what'll happen is that a will actually be the final value that'll be computed. So then we can just return that And yeah, we can see how this goes if we do quick submission. Okay, it's accepted, and you'll notice it's faster than the regular Fibonacci, just doing it recursively solution. Now, so yeah, like there's a lot of different methods to approach the Fibonacci, like the Fibonacci number sequence problem. I think my favorite way is doing it iteratively, because the space complexity, even though the time complexities of all these solutions are the same, the space complexity of this one is O of 1, because you're only just storing these temporary variables. And I just think it's a pretty elegant solution overall. So yeah, thank you for watching, and let me know if you have any questions.